Hello everyone, I'm Rashmi. As a part of graduate rotational internship program organized by the Sparks Foundation, we had to perform the following task and the features of the same I would like to share with you today. So basically we had been provided a data set which had two columns. Basically it had two columns which contains the number of hours students studied and the marks obtained by them. It was a very small data set and we had to perform the following task. We had to build a linear regression model for the same, as well as predict the score of a student who studies for 9.25 hours per day. So these were the following tasks given to us. So in order to perform this task, we had to build a linear regression model. And before we build a linear regression model, there could be a lot of steps like data cleaning, data understanding, data visualization, pre-processing, and everything. So let's go into this procedure step by step. The first step here is importing the libraries. The first two lines of code is just to avoid unwanted warnings which pop up on the screen. And next, I've imported the pandas and the NumPy libraries, as well as the Seaborn. And then from the sklearn library, we have to import the linear regression. This is basically to call the linear regression model into our data set. And then comes the train test split. This is basically to divide our data set into the training part and the testing part. And then to check how accurate our model is, we have to import the mean square error and then matplotlib for the plotting of the graphs. So this is step one. And in step two, we have to understand the data set, for which we'll have to first read our data set. I've just used the direct URL to read my data set. And so this is how my data set looks like. It has number of hours and the scores obtained by a student. And now we have to have a basic idea of how our data looks, for which I've just plotted a simple scatter plot between the number of hours and the scores. The same can be seen here. And we can see that they have a positive correlation between the number of hours studied and the percentage scored. There's a heat map here. The graphical thing, which could be more accomplished here with, we can see that there's 0.98 positive correlation in this case. So this was about the understanding of the data set. So since it has a positive correlation, we are good to apply the linear regression model for this data set. Next, we'll have to check if there are any missing values and take particular actions, but luckily we had no missing values here. And this is described as just to see how our data looks like in the given data set. And here, using the data.info, we can check the data types of the columns. And the shape is basically used to check how many rows and how many columns the data set is having. And next is the classifying of the data as dependent and independent variables. So let's take two variables, X and Y. And I've taken X as the number of hours and Y as the percentage obtained by a student or the scores. And these two lines are basically to reshape the data. There's nothing technical here. It's just a better way of looking into the data. So after understanding which is the dependent and the independent variables, the next step is to build a model. So before building the model, as I said, we have to divide the data as the training set and the testing set. So we have used four variables here: X train, X test, Y train, Y test. And using the train test split, we are letting the test size as 0.1. I've used a 90/10 rule here. Basically, we use 80/20 rule, that is 80% to be the training set and 20% to be the testing set. But since our data is very small, let us use 90/10 rule. So I've given the test size to be 0.1, that is nothing but 10%, and I'm using my training size as 90%. And it's very important to mention the random state value here. It is very important to mention this value. If it is not being mentioned, then every time we run this code, we get different values for my X train and X test. So it could be initialized to any value. For now, let us initialize it to 0. And just to check the shape of my training set now, earlier it was 25. Now you can see that it has become 22. And my testing X test and Y test have turned into just 3 rows because we are just taking 10% of the data set. So after these steps, next step is to actually call the linear regression model. So we are calling the linear regression model here, and we are asking the model to fit my X train and the Y train. So after this step, the data points have been fitted into my linear regression model. And I can check the coefficient and the intercept using the following codes. Now, the Y test of the predicted values can be found using this particular code, where I'm calling model.predict my X test. So basically, I have got these as the values. Similarly, I can check for the Y train predicted values as well. I'm not printing it here. Okay, so the next step is to see how close my actual values and the predicted values are. So if you can see here, my actual values and predicted values are not quite close to, they are close, they're pretty close, but they're not quite close together. So, we are not quite satisfied with the model. Let us try to optimize the model in such a way that we get even more good results. So this graph was basically performed for the test data set, and the same graph performed for a training data set looks like this. And to check the error, this is the equation. We just say mean squared error, Y test, Y predicted test. So this is the code, and we got the mean squared error to be 5.732. And the accuracy was about 92% or 93%, in fact. So in general cases, the above 90% is very good accuracy. But since our data set is very small, let's try to optimize it even more and try to get even more better results. So how do we do it? So the next step is optimizing. So basically in the optimizing part, if you have observed, we had this random state set to 0 in the initial code. And now I keep changing my random state value with about 0 to 10,000 values. I keep changing my I value, and I try to fit my linear regression. I train it, and then I check the accuracy. Whenever my accuracy and all these accuracy values, I'm storing it in a list. In this accuracy list, I'm storing all the values. So when I do this, I can check for different random states what are the accuracy values. So these are the different accuracy values that have obtained. And now let's check which is the maximum accuracy value. And maximum accuracy obtained was 99%. And for that 99%, I'll have to figure out what is my I value, for which I'll use this argmax function to figure out what is it. And random seed value was found to be 6164. Now, I have to train my data set again. With this time, I have to give my random state value as 6164. Again, I have to split it here. And again, I have to call the linear regression model, fit it, and again check the accuracy. The accuracy was found to be 99% as already seen. And the mean squared error also was found to be 2.078, which is comparatively quite less than what we got earlier. Earlier, it was around 5. So 99.02% of accuracy was obtained after optimization. So, by which at this particular stage, 99% accuracy is something really very great. So we are happy with this. And now we had a follow-up question actually. If a student studies 9.25 hours per day, what might be the predicted score? So to find the predicted score, we can import job-lib library here. And I'm just initializing my model to a variable called as my model. And then here I'm calling my model.predict 9.25. What is the predicted marks? And the marks was found to be 93.198%. So a student who studies for 9.25 hours per day will have a predicted score of 93.198%. and provided the seed value is kept to 6164 for the following data set. So this was the prediction that was being performed using the linear regression model. Hope you enjoyed it. Thank you.